Hello, welcome to today's lesson on section 10.4, which is labeled probabilities of disjoint and overlapping events. The way I'm going to go about this lesson, instead of giving you the key concepts, we'll just go straight to some examples, because I think you guys already know what probability is. And in case you forgot, probability is simply the number of favorable outcomes divided by a number of total outcomes. So let's begin with number one. This is from example 1 on page 707 in the book. Find the probability of drawing a face card or a 10 from a standard deck of 52 cards. Okay, standard deck of 52 cards. Hopefully you should know that there are 12 face cards. Remember Jack, Queen, King. And there are 4 tens. So that probably should be really simple. Either one a face card or a 10. So there's 16 favorable outcomes out of a total of 52 outcomes. If you reduce that, I think that comes out to 4 over 13 or 0.308. So pretty simple. But the next one's a little bit tricky. Example 2 on page 708 is where this example's from. Find the probability of drawing a face card or a spade from a standard deck of 52 cards. Okay. And notice how I emphasize the word or, number 1 and number 2, but then number 3 we'll use the word and. So notice the subtle differences of that word when we get through all these examples. So I want a face card or a spade. Again, 12 face cards. And there are going to be 13 spades. So is the probability going to be 25 over 52? Pause and think about that. If you said yes, well, you're wrong. If you said no, you're right. You can't just add them. The reason why there's overlap. 3 of the face cards, 3 of the face cards are spades. So instead what you'd have to do for the probability, you have your 12 face cards, or actually we can look at it this way. We have 13 spades plus face cards that are not spades. And of course, those are spades. So really it should be 22 over 52, which reduces to 11 over 26. There's actually a more elaborate way of finding that, which I'll show you at the end of the video. But in this case, 11 over 26. Okay, let's take a look at number 3. Find the probability of drawing a face card and a spade from a standard deck of 2 cards. Now we're using the word and instead of or, which was what we did before. And this example I just made up, so it's not from the book. So well, if you think about it, again, there are 12 face cards and 13 spades, but we need a card that is both. Obviously 3 cards are both. If you think about it, the Jack, Queen, and King of spades. So that's just going to be 3 out of 52 for your probability. And again, there's also an elaborate way you can find that as well. We'll talk about that at the end. But going back to number 2 again, hopefully you're not confused about that. Just think about it. It can't be 25 over 52. because you have 3 of your face cards that were spades, or you think of it this way, 3 of your 13 spades are face cards. So you got to watch out for the overlap if an overlap does occur. And again, for number 3, the answer is 3 out of 52. Okay, last example, then we'll talk about the key concepts. Find probability not drawing a face card. Okay, so it kind of sounds like a broken record, but there are 12 face cards. And I apologize for the sound. The street cleaners are right outside my house, so hopefully you can still hear me. There are 12 face cards, so 40 are not face cards. So that's easy. That probability will just be 40 out of 52. Or I think that reduces to 10 over 13. Yeah. So what are the key concepts? So disjoint versus overlapping events. Example 1 was disjoint. Example 2 was overlapping. And I guess you could say example 3 as well. So disjoint because 2 events are mutually exclusive. Think about what exclusive means. If you're part of an exclusive club, that means that you're the only person allowed, right? And no one else is allowed. And mutual means together. So it's almost like, it's kind of a, I don't want to say an oxymoron in a way, but it's kind of a weird term. But mutually exclusive means that both events have no overlap. They can't occur together. So 2 events are mutually exclusive, no overlap. So to find that probability, if you look back, all we did was we did 12 out of 52 for the face card, plus 4 out of 52 for a 10, add them up, and that got me the answer. So the probability of A or B for a disjoint situation is simply the probability of A plus the probability of B. Overlapping, I think that's obvious. That's when at least one event or at least one situation satisfies both events, or, I gotta be careful with my wording, at least one outcome satisfies both events. So we look back here, we couldn't just add the probability of a face card, which is 12 out of 52, and a spade, which is 13 out of 52. If you don't believe me, that's not 25 out of 52. Obviously, take a deck of cards and count them. You'll see for yourself there's only going to be 22 cards that are face card or a spade. So anyway, notice how we got 25 over 52 if we add these two. And notice how for number 3, we have 3 out of 52. What happens if you combine those two things? If you subtract those two things, what do you know? You get 22 out of 52. So what that means is that for an overlapping event, the probability A or B is the probability of A plus the probability of B minus the probability of A and B. So if you ever have a tough probability situation where you have to find the probability of two things occurring at the same time and you can't really think about what that is, you can find the probability of each event occurring individually and the probability of A or B if you knew what that was, and you can find the probability of A and B. So you can actually do some little bit of algebra with these kind of problems. And we'll look at that when we do the classwork on Friday. And the probability of not A, well, if we think about it, the probability of getting a face card is 12 out of 52. And the probability of not getting a face card was 40 out of 52. What do these two add up to? Notice that they add up to 1. right? One being 100%, because 100%, either you have it or you don't. So the probability of something not happening is one minus probability that it does happen. So for example, the probability that rains today is 20%. The probability doesn't rain is 80%. That's all. Pretty simple stuff. So I think that concludes the video. And if you didn't finish 10.3 during block 2 this week, that's because we were enjoying pi and, I don't know, just explaining some of the previous work. You'll have a chance to finish it on Friday, but I'm also going to tack on some more work, so we really have to get kind of serious on Friday, even though March Madness is upon us. Actually, it starts in 1 hour, come to think of it. Anyway, I'm all done. I got to get ready to go to campus, so I'll see you guys later. Goodbye.